Formative 1, Part A, is reading the text and annotating it. Again, we're going to be evaluating you using this annotation rubric based on what you highlight in the text and your answers to the questions that we give you to guide your margin notes. So as you and I are reading, you're going to highlight details that help describe the different layers of atmosphere and their properties, like their temperature, their pressure, and their density. And then after each paragraph, you're going to stop and jot to summarize main ideas, make connections, and ask any questions that you may have. In this version, I have given you additional guiding questions to help support your stop and jots after each paragraph. Okay. Introduction. Earth's atmosphere is the only planet in the solar system with an atmosphere that can sustain life. Sustain means maintain, help keep alive, right? Our atmosphere has a mixture of gases. 78% is nitrogen, 21% of it is oxygen, leaving only small amounts of water vapor, which I know is a gas, carbon dioxide, and other greenhouse gases. So that seems important. I'm going to go ahead and go to the highlight feature for this document and highlight that. And if you don't remember what greenhouse gases are, let's go down to the footnote. Greenhouse gases are certain gases in the atmosphere, like water vapor, carbon dioxide, nitrous oxide, and methane, that trap energy from the sun. Okay. The blanket of gases that contains the air that we breathe. Oh, that's a typo, sorry. It's supposed to say, this blanket of gases not only contains the air that we breathe, but it also protects us from the intense heat and radiation coming from the sun. It also warms the planet by day, and it helps cool the planet by night. So let's say that it not only contains the air that we breathe, right, but also protects us from intense heat and radiation and warms the planet. Right, so you see that my highlights not only have little fragments of a sentence, but they highlight details that help answer this question, which is, what is the paragraph's main point about the atmosphere? I'm going to say the atmosphere is made of gases which helps us by containing the air we breathe, warming the planet, and protecting us from harmful radiation from the sun. And I see here is like a little preview of what we're going to read more in depth, just pointing to and labeling these different layers of the atmosphere. And I see that in order to get to the Earth, the solar radiation from the sun has to travel through all of these atmospheres. So let's see what this text says next. So let's see what we're going to be looking for. What's the main idea about the layers of the atmosphere? And I see here there's another diagram showing me the different layers of the atmosphere, and it looks like it labels the names of each layer. So let's see. The atmosphere can be divided into 4 layers based on temperature variations. Again, variation meaning differences. Okay, so I know that these different layers of the atmosphere must have different temperatures. The layer that's closest to the Earth is called the troposphere. Above this layer is the stratosphere, followed by the mesosphere, and then the thermosphere. The imaginary boundaries between these layers, shown in the image to the right, are known as the tropopause, that's here, between the troposphere and the stratosphere. The stratopause, you see this boundary separating the two layers? That's the stratopause. It's between the stratosphere and the mesosphere. The mesopause, which is between the mesosphere and the thermosphere. Temperature variations in the four layers are due to the way that gas molecules in each layer absorb radiation from the sun as it travels down to Earth. So now that we highlighted that together, I'm going to let you stop and jot your notes, explaining what the main idea is here about the atmosphere. So I know it has to do something with temperature and layers. You can go ahead and pause this while you write your stop and jot, and then press play when you're ready to move on. Since the Earth's surface is made of solid and or liquid matter, Earth's surface absorbs much of the sun's energy. Some of the sun's energy is re-radiated back from the Earth as heat. That means that's like shown right here. Oh, I'm sorry. Yeah, okay. I'm done. And some of that heat escapes to space. It's like happening back here. This process is what warms the troposphere. The troposphere is also where all the weather we experience happens. Okay, so let's see. So now you're going to write your one-sentence summary describing what they say about the troposphere and how it maintains its temperature. Once again, you can pause this as you write your summary and then press play when you're ready to move on. The global average temperature in the troposphere rapidly decreases with altitude until the tropopause, which is again the imaginary boundary between the troposphere and the stratosphere. The temperature begins to increase with altitude in the stratosphere. That means that, so let's go back to our diagram here. So we see that temperature is decreasing as you get higher because more energy is being lost. You're getting farther away from the surface of the Earth, which is the hottest part in this diagram, right? So it makes sense that as you get farther and farther away, it gets cooler until it says until we get to this boundary, the tropopause, and then after this boundary, temperature also actually starts to increase. It starts to get hotter. Why? Well, let's see what it says. This warming is caused by a form of oxygen called ozone. So I'm going to go ahead and highlight that, which absorbs UV radiation from the sun. By doing this, ozone protects us from most of the sun's ultraviolet radiation, which can cause cancer and sunburn. So in this one-sentence summary, you're going to summarize information about the temperature differences between the troposphere and the stratosphere. You might want to start with something like, in the troposphere, the temperature is hotter the closer you are to the land and Earth's surface. As you move farther up in altitude, the temperature gets colder until you get to the tropopause. Then, in the stratosphere, the temperature, and you can go ahead and finish that sentence. Okay. At the stratopause, the imaginary boundary between the stratosphere and the mesosphere, temperature stops increasing with altitude. So I'm going to go ahead and highlight stratopause, and temperature stops increasing with altitude. then the mesosphere does not absorb radiation, so the temperature decreases with altitude, kind of like how it did in the troposphere. At the mesopause, the temperature begins to increase with altitude. And this trend continues in the atmosphere. Here, solar radiation first hits the Earth's atmosphere and starts to heat it. Because the atmosphere is so thin, a thermometer cannot measure the temperature accurately, and special instruments are needed. So let's see, how can we summarize temperature differences between the stratosphere and the mesosphere? So after the stratosphere, at the stratopause, temperature stops getting hotter the higher you go, or the higher you get in altitude. And what if we say, since the mesosphere does not absorb heat from the sun, right, that's solar radiation, the temperature does what with altitude? Increases or decreases? Then, at the mesopause, the temperature starts to increase again as you go higher. Okay, so now that we're done reading, let's go and see what part B of this formative assessment is. Complete the 2 sets of questions below, which help you interpret the diagram by showing differences in pressure and temperature between the different atmosphere layers. Okay, so I see this. It's showing me the temperature, the pressure, the concentration, and of each layer, the troposphere, stratosphere, mesosphere, and thermosphere, as you go up in altitude. And it's showing me kilometers, or if you prefer miles, miles. So what are the 4 variables being measured? Altitude, temperature, pressure, and concentration. How is temperature measured on this graph? Let's go to temperature. What's the unit of measure? Degrees Celsius. How's pressure measured on the graph? This ATM, remember? I'm not sure if you remember from the Earth's interior layers, but ATM means atmospheres. Atmospheres. Okay. What inferences can you make about the relationship between altitude, temperature, and pressure? So let's say something like, as altitude increases, what happens? Temperature increases in the troposphere. Let's say like here, in the troposphere, as altitude increases, temperature in the stratosphere, as altitude increases, temperature. Well, let's look at pressure. So we see that temperature and concentration are not as fluctuating as the temperature. So we see that the pressure at the the pressure has more of a linear growth. So as altitude increases, what happens to pressure? As altitude increases, what happens to concentration? All right, so you can go ahead and finish your responses there. I'll give you a sentence starter. Now, this is important. Before you do the next set of questions, you should rewatch this video describing the Earth's layers of the atmosphere and then answer these questions. Good luck.